A stream of gas escapes at 150 kilograms per second, yet no recoil is measured. Observer, that single number has drawn you here, carried quietly by gravity and curiosity alike. You did not arrive by chance. The cosmos has a way of placing questions in front of those ready to notice them. What if the odds were never random at all? What are the chances that an interstellar object would shed mass brush past Mars and remain unnervingly steady in its motion? The data speaks softly. Non-gravitational forces cancel themselves out. A trajectory that grazes three worlds. A silence where acceleration should be. Out there, a fragment of another star glides through the dark, luminous, and unresolved. Stay a while, traveller. Let's drift through the silence together. Tonight the universe whispers again. Far from the noise of Earth, beyond familiar planets and habitual orbits, an interstellar object moves through the dark with a calm that feels almost intentional. Astronomers call it Three-Eye Atlas, but names are only labels we attach to motion. What matters is what the light tells us. Photons reflected from dust and gas reach our telescopes carrying a quiet contradiction. This object releases material like a comet should, yet its path remains steady, unperturbed, as if gravity itself has agreed to let it pass undisturbed. You are not lost in space, you are part of it, and tonight you are here to listen. In classical astronomy, motion is a patient conversation between mass and force. When ice warms near a star, gas escapes. Momentum shifts. Orbits respond. This principle has guided generations of observers from Newton's careful calculations to modern orbital models refined by computers that track positions to fractions of an arc-second. With Three-Eye Atlas, the familiar script falters. Telescopes see a coma of gas surrounding the nucleus, faint streams of dust forming a tail shaped by radiation and solar wind. Spectrographs confirm active chemistry. Carbon dioxide molecules glow in infrared light. Cyanide appears rising gently as the object draws closer to the sun. Everything suggests activity, and yet the orbit does not flinch. Non-gravitational acceleration is a quiet but dependable signal. It is the subtle drift caused by escaping gas, the same physics that nudges comets into slightly altered paths over time. For most comets, this effect is as reliable as dawn. Gas leaves the surface. The body responds. With Three-Eye Atlas calculations return only upper limits. No clear push. No measurable deviation beyond gravity alone. It is as if the forces cancel themselves before leaving a trace. Statistics murmur where they should speak. Residuals fall into the noise. Silence takes the place of certainty. Listener. This silence does not feel empty. It feels deliberate, though astronomy teaches caution with such words. The sky is filled with patterns that appear intentional, until patience reveals natural order beneath them. The question is not whether something strange is happening, but how gently we allow uncertainty to remain. Data from Hubble traces the evolving shape of the coma. James Webb resolves chemical ratios with exquisite sensitivity. Ground-based observatories follow the object night after night as it drifts against the dense star fields near the galactic center. Every instrument agrees on the facts. Gas flows, dust lifts, the path holds steady. Such balance invites reflection. One explanation rests in symmetry. If outgassing emerges evenly across the surface, thrust vectors cancel, leaving little net motion. In theory, this can happen. In practice, perfect balance is rare. Comet surfaces are uneven, marked by pits, fractures, and regions of uneven heating. Yet rarity does not mean impossibility. Another explanation turns to mass. If the nucleus is far heavier than its brightness suggests, then ordinary outgassing may simply be too weak to move it. A mountain does not respond to a breeze. Numbers hint at this possibility. Estimates derived from gas production and absent acceleration suggest a mass far larger than expected, though uncertainty remains wide. Astronomy often lives within such margins. Silence is the language of distant worlds. Interstellar objects arrive without context, carrying histories written elsewhere. Before entering our solar system, Three-Eye Atlas wandered for millions of years between stars exposed to cosmic rays and cold so deep it erases memory of warmth. Its chemistry may reflect a birthplace unlike our own. Carbon dioxide dominates where water usually rules. Nickel appears without its usual companion iron. These signatures may feel unsettling, yet they also expand the catalogue of what nature can assemble. Difference does not imply design, it implies diversity. Still, the mind lingers on contrast. Our first interstellar visitor, Oumuamua, showed acceleration without visible gas. Our second, Borisov, behaved exactly like a familiar comet. Now this third traveller offers the inverse of the first: visible activity without measurable push. 3 objects, 3 lessons each, challenging a different corner of expectation. Statistics would caution against drawing sweeping conclusions from such a small sample. But curiosity thrives in precisely these gaps. Somewhere beyond our reach, something ancient still moves indifferent to our categories. The discovery of Three-Eye Atlas itself unfolded quietly. Archival images held it long before recognition. Only when motion betrayed its unbound trajectory did attention sharpen. Hyperbolic paths speak of exile from another star. Once confirmed, the object became a shared focus for observatories across Earth and beyond. Dates, distances and angles were refined. Closest approach was mapped, safety confirmed. There was never danger here, only opportunity. A narrow window to watch, measure, and then let go as the object recedes once more into the dark. Traveller moments like this remind us that astronomy is not a search for certainty alone, it is a practice of humility. Every measurement is an act of listening, every model is provisional. We test ideas not to conquer mystery, but to understand how much remains untouched by explanation. The absence of non-gravitational acceleration may yet resolve itself as data accumulates, or it may remain a quiet footnote that reshapes theory years from now. Both outcomes are acceptable. Science does not rush sleep, it waits. As nights pass, photons continue their journey. They cross space-strike mirrors and are translated into numbers that drift across screens in control rooms lit only by red lamps. Outside, the sky turns slowly. Planets keep their courses. Three-Eye Atlas glides onward, shedding a little more gas, reflecting a little more light, leaving behind no message except motion itself. Tonight it is enough to observe without demand. It is all right to not know. The stars are under no obligation to explain themselves. Sleep, traveller. The cosmos remembers. Tonight the universe whispers again, not through spectacle but through patience. After the first recognition of Three-Eye Atlas as an interstellar visitor, the work of astronomy slowed into its natural rhythm. There was no sudden revelation, no single image that revealed its nature all at once. Instead, understanding unfolded the way starlight always does, incrementally, photon by photon, night after night. Early observations showed little more than a faint point sliding across dense stellar fields, nearly indistinguishable from the background. At first glance, it was just another quiet speck in a sky filled with countless others, each one minding its own orbit. Only motion gave it away. Its speed did not match the sun's gravitational expectations. Calculations revealed a hyperbolic trajectory, the unmistakable signature of an object not bound to our star. It had arrived from elsewhere, from a place beyond familiar constellations and known formation histories. This realization did not arrive with drama. It emerged from spreadsheets, residuals, and careful cross-checks between observatories. Astronomy often announces its most profound discoveries, not with fanfare, but with agreement. As confirmation spread, telescopes turned their attention more deliberately. With time, the point of light softened into a diffuse glow. A coma appeared thin at first, then gradually more pronounced. Dust and gas began to trace faint structures shaped by sunlight and solar wind. These changes followed a rhythm well known to comet observers. As distance to the sun decreased, activity increased. Nothing about this phase felt rushed. The object seemed content to reveal itself at the same pace as every other natural body responding to stellar warmth. Photometry recorded a steady brightening. Numbers shifted quietly in databases as magnitudes were revised and refined. Some early estimates suggested rapid change, but careful analysis reminded observers of how easily geometry can mislead. Viewing angle phase effects and expanding dust clouds can amplify brightness without implying sudden physical transformation. Here, restraint mattered more than excitement. Each data point carried uncertainty, and uncertainty was treated not as failure, but as an honest companion. Images from space-based telescopes added texture to the story. Hubble captured a plume oriented toward the Sun, delicate and precise, confirming active outgassing. At times, faint features appeared that seemed to contradict expectation dust extending in directions that felt reversed. These anti-tail structures were not messages or anomalies, but perspective made visible. Dust released weeks earlier spread along the object's orbit, briefly aligned with Earth's line of sight. Geometry performed a quiet trick, and the sky obliged by letting us notice it. Ground-based observatories followed these changes patiently. Gemini South and the Very Large Telescope traced the evolution of the tail as solar radiation pressure took control. Over weeks, unusual features gave way to familiar forms. Dust streamed outward. Gas diffused into space, and the comet-like identity of the object became clearer with every observation. If one listened closely, the data seemed to say that difference does not always mean defiance. Sometimes it simply means variation. Yet beneath this surface, normality, questions remained suspended. If activity was this visible, if material was clearly leaving the nucleus, why did the orbit remain so calm? The contrast sharpened as observations accumulated. Most comets announce their activity twice, once through light and again through motion. Here only light spoke. The equations returned to their resting state gravity, only solutions fitting the data as comfortably as they always had. The absence of acceleration did not grow louder. It stayed soft, persistent, unresolved. Chemistry deepened the meditation. Spectra revealed carbon dioxide in abundance, far outweighing water vapor. This alone set 3I Atlas apart from most solar system comets. Carbon dioxide behaves differently under solar heating. It sublimates more evenly, less prone to forming narrow jets that impart strong directional thrust. This raised a gentle possibility. Perhaps the same chemistry shaping the coma also shaped the dynamics. Perhaps balance, not intervention, explained the calm. Nickel added another layer. Emission lines appeared clearly while iron remained absent. In many comets, these metals travel together, released from dust grains under solar radiation. Here they did not. Several explanations rested comfortably within known physics. Different volatility thresholds, surface processing during long interstellar travel, selective release from complex molecules, none required invention, all required patience. Astronomy does not demand answers on a schedule. The object's journey toward perihelion continued each day slightly warmer than the last. Models updated gently, production rates rose as expected, cyanide increased, carbon dioxide glowed more strongly. The chemistry followed the sun step by step, obedient to thermodynamics. There was no sign of internal heat, no deviation from radiative balance. Everything responded exactly as physics would suggest, except the orbit, which remained serenely unchanged. In this tension between expectation and observation, science finds its quiet beauty. Data does not need to shock to be meaningful. Sometimes its value lies in how calmly it resists interpretation. The story of 3I Atlas during these months was not one of escalation but of steadiness. Each night added clarity to some aspects and deepened mystery in others. This is not contradiction. It is the natural state of exploration at the edge of knowledge. Silence is the language of distant worlds, and this object spoke it fluently. It did not hurry. It did not announce intent. It moved as it wished, leaving behind a trail of photons and probabilities. Observers watched instruments, recorded theories, adjusted their posture slightly, like sleepers shifting in the dark. Nothing demanded resolution yet. The universe was content to let the question breathe. As the object approached its closest point to the sun, anticipation remained measured. Increased heating might amplify outgassing. Subtle acceleration might finally rise above detection thresholds. Or the balance might hold, carrying the mystery forward untouched. Both outcomes were acceptable. Knowledge advances as much through confirmation as through restraint. For now, it is enough to acknowledge what has been seen. A visitor from another star, active, yet steady, chemically unusual, yet physically calm. A reminder that nature often occupies corners of possibility we have not yet explored. Tonight the stars will keep their silence. And within that silence, understanding rests, unhurried, waiting for sleep. Tonight the universe whispers again, not with new images, but with numbers that refuse to settle. As observations of Three-Eye Atlas continued attention turned from what could be seen to what could be inferred. In astronomy, the most revealing motions are often the smallest ones hidden within residuals and uncertainties that only emerge after long, patient watching. Non-gravitational acceleration belongs to this quiet category. It's not a force that announces itself, but a subtle imbalance, a deviation so small it must be coaxed out of data gathered over months. To measure such effects, astronomers practice a kind of disciplined stillness. Positions are recorded against distant stars night after night. Every known influence is accounted for. The pull of the sun, the gentle tugs of planets, relativistic corrections that matter only when precision demands humility. What remains after these influences are subtracted is examined carefully. Patterns, if they exist, reveal themselves slowly. With 3 Atlas, this process yielded little more than calm. Upper limits replaced detections, discussions replaced declarations. Papers spoke in careful language describing what could not yet be confirmed, rather than what had been found. This restraint was not reluctance. It was respect for uncertainty. In the absence of clear acceleration, models defaulted to gravity alone, and gravity proved sufficient. The equations closed neatly, as if the object were content to follow the simplest path available. Such simplicity invites deeper thought. Outgassing, after all, is not rare. Comets do it constantly. When ice sublimates, gas leaves the surface at hundreds of meters per second. Momentum must be conserved. Motion must respond. That is the rule. But rules operate through conditions, and conditions vary. One possibility is symmetry so precise that thrust cancels itself. Jets emerging from opposite regions balance like breath exhaled evenly on both sides of a scale. In theory, this can occur. In nature, it is uncommon, but not forbidden. Rotation complicates the picture. Most small bodies tumble or spin, exposing different regions to sunlight over time. This changing illumination usually produces time-varying forces that leave detectable signatures in orbital fits. For 3 Atlas, the absence of such signatures suggests either an unusual rotational state or a surface composition that smooths out these variations. Carbon dioxide plays a role here again. Its tendency to sublimate more evenly than water offers a pathway to quiet balance. Listener, these ideas are not conclusions, they are meditations. Astronomy advances not by choosing the most dramatic explanation, but by eliminating those that fail under scrutiny. Artificial control has been suggested by some, not because evidence demands it, but because anomaly invites imagination. Yet imagination must always bow to measurement. So far, measurement allows natural explanations to stand. Nothing in the data requires intention. Nothing demands design. Mass enters the conversation softly through equations that link thrust to response. If the nucleus of 3-Eye Atlas is far more massive than typical comets, then outgassing would have little effect. The same force that nudges a pebble will barely move a boulder. Estimates derived from gas production rates and absent acceleration hint at this possibility. Numbers suggest a mass comparable to a small mountain compressed into a body that reflects little light. Such density would be unusual, but interstellar space is a factory of extremes. Uncertainty remains wide. Brightness can mislead. A large dark object and a small reflective one can appear similar through a telescope. Coma light overwhelms nucleus light masking true size, until imaging resolves. The solid core directly mass estimates will drift within broad margins. This is not failure. It is the honest state of inference at great distance. Comparisons offer perspective. Oumuamua, the first interstellar visitor, showed the opposite behaviour. No visible gas, yet clear acceleration. Its motion sparked years of debate, from radiation pressure to exotic compositions. Borisov II behaved exactly as expected. Water sublimated. The rocket effect appeared on schedule. Its orbit responded politely to physics textbooks. Together, these 3 objects outline a spectrum rather than a pattern. normality at one end, contradiction at the other, and quiet ambiguity in between. Statistics whisper caution. 3 data points do not define a population, yet they hint that interstellar objects may be more diverse than those born around our Sun. Different formation environments, different chemistry, different thermal histories. Our models refined on local samples may simply be incomplete. This is not a threat to science. It is its invitation to grow. Benchmarks from within the solar system reinforce humility. Comet 67P studied up close by, Rosetta confirmed the rocket effect with exquisite clarity. Jets, forces, and orbital changes aligned perfectly with prediction. Larger comets, like Hale-Bopp, also exhibited measurable acceleration despite their size. These cases remind us that mass alone does not erase motion. Something about 3I Atlas still sets it apart, whether through balance scale or timing. Time itself matters. Detecting tiny accelerations requires long baselines. Interstellar visitors move quickly. They are often discovered late in their approach, leaving limited opportunity for accumulation of subtle effects. What appears absent today may emerge tomorrow as residuals grow and uncertainties shrink. Patience is not optional, it is the method. As weeks pass, data continues to gather. The object warms, production rates rise, photons stream in, the orbit remains calm. This persistence deepens the question without sharpening it into alarm. In the language of science, this is a productive state. It encourages better models, more careful observations, and quieter claims. You are not lost in space, you are part of it. To observe is to participate. To accept uncertainty is to align with the cosmos, which rarely offers immediate clarity. 3I Atlas does not demand belief or suspicion. It invites attention. It asks us to notice how easily expectation can be unsettled by a single, calm trajectory. In the end, non-gravitational acceleration may appear resolving the tension in familiar terms, or it may remain elusive, forcing refinement of how we think about outgassing symmetry and mass. Either outcome enriches understanding. Science does not require mystery to vanish. It only asks that mystery be approached with care. Tonight the stars will keep their silence. The equations will rest where they are. And somewhere beyond our reach, something ancient still moves, obeying laws we mostly know, and a few we're still learning how to hear. Tonight the universe whispers again, this time through chemistry rather than motion. As attention shifted from trajectories to spectra, light itself became the storyteller. When photons from 3I Atlas were separated into their constituent wavelengths, they revealed a composition both familiar and quietly unfamiliar. Spectroscopy does not speculate, it measures. It records how atoms and molecules absorb and emit light, leaving signatures as precise as fingerprints. In those signatures, astronomers began to sense why this object feels different without feeling dangerous. The most prominent feature was carbon dioxide, not merely present but abundant. Its infrared bands dominated the spectrum, far exceeding what is typically seen in comets formed around our Sun. Water vapour, usually the primary driver of cometary activity, appeared secondary here. Carbon monoxide was present but subdued. This balance matters. Carbon dioxide sublimates at lower temperatures than water ice, and does so in a more distributed way across a surface. Instead of erupting from isolated vents, it can seep outward more evenly, creating activity without strong directional force. Chemistry in this sense becomes a form of geometry. Alongside these volatiles appeared a subtler signal. Nickel emission lines emerged clearly while iron did not. In many solar system comets, these metals arrive together liberated from dust grains under solar radiation. Their partnership is almost expected. Here, the partnership was broken. Nickel spoke alone. This absence of iron did not shout. It murmured, inviting interpretation without insisting on one. Several natural explanations offered themselves quietly. Different binding energies, selective release from complex molecules, long exposure to cosmic radiation, altering surface chemistry over interstellar time. The James Webb Space Telescope refined these impressions with extraordinary clarity. Its instruments traced molecular ratios with precision impossible from Earth's surface. The CO2 to H2O ratio stood among the highest ever measured in any comet, local or interstellar. This suggested formation in an environment unlike the cold water-rich regions that shaped most comets we know. Perhaps this object formed nearer a carbon dioxide ice line around a different type of star. Perhaps its natal disk followed chemical gradients unfamiliar to our solar system. Formation history leaves its memory and composition. These chemical details fold back into the dynamical mystery. If carbon dioxide dominates outgassing, may naturally resist producing a net push. Multiple weak sources distributed across the surface could cancel one another's momentum transfer. Jets may exist without dominance. Motion remains calm not because forces are absent, but because they are shared. Balance emerges not from control, but from distribution. The universe often prefers equilibrium to emphasis. Traveller, this is where wonder and restraint meet. It is tempting to treat unusual chemistry as a code or a clue pointing beyond nature. Yet chemistry is one of the most versatile storytellers in the cosmos. It adapts to environment, temperature, radiation, and time. Interstellar space is not empty. It is an active laboratory where surfaces are altered over millions of years. What appears strange to us may be ordinary elsewhere. Difference does not require intention. Temporal behaviour adds to this calm picture. As 3Psi Atlas approached the Sun, production rates of carbon dioxide and cyanide increased steadily, tracking solar heating as physics predicts. There were no abrupt shifts, no pulses out of phase with distance. The chemistry responded smoothly, obedient to thermodynamics. Nickel emission rose gradually as well, suggesting progressive release rather than sudden exposure. Iron remained silent. Silence here is still data. Imaging reinforced this steadiness. Hubble and ground-based telescopes showed evolving plumes and tails, but nothing inconsistent with natural responses to changing illumination and solar wind. Early anti-tail features faded as geometry shifted. Later, dust streamed outward in familiar arcs. Radiation pressure sculpted the scene. Solar wind whispered through charged particles. Nothing required new forces. Everything followed old rules applied in a new context. This combination of unusual composition and ordinary response invites reflection on how limited our expectations may be. For decades, comet science has been built on a sample drawn almost entirely from our own stellar neighbourhood. We learned patterns, refined them, and began to treat them as norms. Interstellar visitors challenge that comfort gently. They ask us to consider that our norms may be local customs rather than universal laws. The absence of iron alongside nickel remains unresolved, but unresolved does not mean alarming. It marks an open question, not a closed door. Models explore selective sublimation pathways. Laboratory studies test how metals behave when bound within exotic compounds. Time will refine these ideas as it always does. Science does not hurry its conclusions. It allows them to condense slowly like frost forming on a cold surface. As perihelion approaches, attention remains patient. Increased heating may amplify signals or reveal new species. It may also simply confirm the patterns already seen. Either outcome would be instructive. Persistence without escalation is itself a form of information. It suggests stability, not secrecy. It suggests that the universe is comfortable letting us watch, without revealing everything at once. You're not lost in space, you are part of it. The chemistry unfolding around 3I Atlas is the same chemistry that shaped planets' atmospheres and eventually life. Carbon, oxygen, nitrogen metals forged in ancient stars, all participating in a slow dance around a different sun than the one we call home. This continuity is comforting. It reminds us that even visitors from beyond carry familiar elements, rearranged but not alien in essence. The question of artificial influence arises only because silence invites projection. When motion does not behave as expected, the mind reaches outward. Yet the data so far remains generous to natural explanation. No spectral line demands technology. No energy balance implies regulation beyond physics. No temporal pattern encodes intention. What we see is rare, but rarity is not violation. It is simply the tale of a distribution we have barely begun to sample. As nights pass, the object continues its quiet approach. Telescopes record. Analysts update models. The universe remains untroubled by our curiosity. Somewhere beyond our reach, Something ancient still moves, shedding molecules into sunlight, obeying entropy, reflecting photons that eventually find our instruments. This is enough. It is all right to not know. Chemistry has spoken softly, and motion has answered with restraint. Together, they form a meditation rather than a message. Tonight the stars will keep their silence. And in that silence, sleep comes easily carried by the understanding that mystery does not threaten meaning. It deepens it. Tonight the universe whispers again, as 3 Atlas begins its long departure from our attention. After months of observation, reflection settles where urgency never belonged. This final passage is not about resolution, but about perspective. In astronomy, endings are rarely conclusions. They are pauses, places where data rests and meaning continues to evolve beyond the limits of a single apparition. As the object recedes, it carries nothing away from us. Everything it offered has already arrived, as light as numbers, as carefully measured uncertainty. Its trajectory will soon blend back into the background of interstellar space, indistinguishable from countless other travellers passing unseen. This is not loss. It is the normal rhythm of a universe that does not linger for witnesses. The central tension remains gentle, visible activity without measurable acceleration, chemistry that feels unusual without demanding invention, mass that may be extreme or merely misunderstood. None of these questions require immediate answers to be valuable. Science advances through accumulation, not revelation. What matters most is not what 3i Atlas turns out to be, but what it teaches us about how to look. For decades, the search for intelligence beyond Earth has focused on signals, radio waves, optical flashes, deliberate beacons aimed across space. Yet physical objects also speak, though, in quieter dialects. Their orbits, compositions, and thermodynamic behaviour encode histories that no transmission can disguise. Interstellar visitors expand the conversation, reminding us that evidence does not always arrive as a message. Sometimes it drifts silently through the solar system, asking only to be measured with care. This does not require suspicion. Natural explanations remain sufficient. Carbon dioxide dominated outgassing can soften thrust. Symmetry can cancel motion. High mass can absorb force. These mechanisms may operate together, producing behaviour that feels improbable only because our experience is narrow. The universe is under no obligation to resemble our expectations. It only asks that we update them honestly. Listener, there is peace in this uncertainty. The absence of final answers does not diminish meaning. It deepens it. Each interstellar object becomes a calibration point, a reminder that our theories are provisional maps rather than territories. With more discoveries, patterns will emerge. Some objects will behave like Borisov. Some will surprise us like Oumuamua. Others will rest quietly in between like 3's Atlas, teaching patience through balance. The coming years will transform this field. New surveys will widen our view. Detection rates will rise. Statistical context will replace anecdote. What feels singular now may one day feel representative, or it may remain unique, a solitary case that sharpened our tools and then faded gracefully from relevance. Both outcomes are meaningful. Science does not demand that every mystery endure. What remains constant is method, careful observation, conservative interpretation, willingness to revise without rushing. 3i Atlas has already served this process well. It prompted collaboration across observatories. It refined techniques. It tested assumptions. Even if no further anomaly emerges, these contributions persist, folded quietly into the collective understanding of small bodies and distant systems. Somewhere beyond our reach, something ancient still moves, not because it wishes to be seen, but because motion is its nature. Our brief awareness of it is incidental yet valuable. We are witnesses, not participants, and that is enough. To watch without grasping is a form of respect. You're not lost in space, you are part of it. The same physics shaping this visitor shapes planets, atmospheres, and minds capable of wonder. The same uncertainty that frustrates explanation also makes discovery possible. Without it, curiosity would have no place to rest. As this story settles into archival data and future citations, its quiet influence remains. It reminds us that the universe offers complexity without malice, mystery without urgency, and questions without deadlines. Acceptance is not surrender. It is alignment with a cosmos that unfolds on scales larger than comprehension. Understanding arrives slowly, like frost forming on distant metal unseen, until morning light reminding us that patience is not passive, but the most active stance inquiry can take within the vast night sky. Tonight the stars will keep their silence. Sleep, traveller, the cosmos remembers, as our time with new 3i Atlas data reveals the impossible. As it closes in on Mars, science for sleep gently comes to rest. The universe grows quiet once more. The data settles, the questions remain. Somewhere beyond our sight, an interstellar object continues its journey, carrying no answers, meant for us alone only reminders of how vast reality truly is. Traveller, we followed this visitor through numbers and light through chemistry and motion, and discovered something subtle. Not certainty, but humility. The cosmos does not rush to explain itself. It invites patience. It allows wonder to exist beside doubt and silence to coexist with knowledge. What we witnessed was not conclusion but a moment of connection. An object born around another star passed briefly through our awareness, and in doing so expanded the edges of what we thought we understood. We are small beneath the sky, yet not insignificant. To observe is to participate. To listen is to belong. The mystery continues quietly unfolding far beyond our reach. The universe is still alive, still whispering, still moving through time without urgency. Rest now beneath the stars. Stay curious. The universe will keep watch.